Hello, welcome back once again. Today we have this interesting Olympiad mathematics problem. We're given that root x all over x whole raised to the power of x minus 1 is equal to x all over root x whole raised to the power of x minus 3. So in this video, we're going to solve for all possible real values of x that will satisfy this equation, right? One can easily say that x cannot be equal to 0. You know why? Remember, we have division by x right over here. We also have division by root x. If x is equal to 0, we have division by 0 here. We also have division by 0 here. So therefore, x cannot be equal to 0. Okay? Now let's take note of this. Remember, the two bases are similar. Just that one is the reciprocal of the other one, right? Now take note of this. When we have a over b whole raised to the power of n, so this is equal to, if you want to interchange a and b as b all over a, then we're going to have a negative power. So we're going to apply this property at the left hand side. Now from the left hand side, we're going to apply this property at the right hand side. So sorry for that. Now at the left hand side here, we have square root of x divided by x whole raised to the power of x minus 1. This is equal to x divided by root x whole raised to the power of x minus 3. Now this property, apply it at the right hand side. We're going to have square root of x all over x whole raised to the power of x minus 1. This will be equal to, so here we're going to have square root of x divided by x. Then we're going to have a negative power of 1. And then remember, we have this x minus 3. So from here now we have root x all over x whole raised to the power of x minus 1. So this is going to be equal to root x all over x, right? Then whole raised to the power of negative 1 times negative 1 multiplied by x minus 3. So from here we have root x divided by x whole raised to the power of x minus 1. So this will be equal to root x divided by x whole raised to the power of, this is negative 1 times x is negative x, negative 1 times 3 here will give us positive 3, right? Negative 1 times negative 3 is positive 3. So this is same as 3 minus x. Cool. Now from here we have two cases, right? Remember, we have the same base, we can equate the power. So we have our first case. Our first case here is to consider this, that 1 raised to the power of k is equal to 1 for all k, right? For all k. So if you consider this here, so we're going to let either this base or this one equals 1. So we're going to do this following. Root x divided by x is equal to 1. Now we know x cannot be equal to 0, right? So cross multiply, we get root x is equal to x times 1. That will give us x. Square both sides. From here we get, if you square both sides, this square cancel the square root, we have x is equal to x squared, right? Now subtract x from both sides. This is same as x squared minus x is equal to 0. Take away x, we have x into bracket x minus 1 is equal to 0. So from here we have x is equal to 0 or x is equal to 1. So indeed 1 is a solution, but we know 0 cannot be a solution. And then we have our second case here. Our second case is when we have a raised to the power of b, that this is equal to a raised to the power of c. Since we have the same base, so this implies that b, is that how to write b? Oh my god. So b is equal to c. So using that idea, we see we have the same base, so we're going to equate the exponents. So this is going to give us that x minus 1 is equal to 3 minus x. If this x, negative x is crossing over, it becomes positive. If this negative 1 is crossing over, it becomes positive. So this is the same as x plus x is equal to 3 plus 1. So from here we have 2x is equal to 4. Divide both sides by 2, we have a solution of x is equal to 2. Now we have the following solutions for x. We have x is equal to 1 and x is equal to 2. and these are the only real solutions that satisfy the given equation. Thank you for watching. Please, if you really enjoyed the video, kindly subscribe to my channel. Also like, comment and share.